There's this idea that if it's wet, it's bad for business. But there is something we can learn from the way water flows in nature, because it turns out what is good for wetlands is also good for us. Because while half the planet is covered in wetlands, almost none of us know anything about them. So let's get to it. This is a series that explores the hidden world of wetlands, why they matter, how they work, and what we can do to protect them. That's because it's not just the water that makes a wetland, it's also the way that water behaves in and around it. And the more connected a wetland is to flowing waters like rivers or streams, the healthier and more resilient it is. Without these connections, a wetland can fill up and spill over its banks, flooding nearby areas. It allows animals to move in and out of the wetland as conditions change or as they search for food or mates. It gives plants access to fresh sources of nutrients, and it provides us with opportunities for recreation and even drinking water. And that's on top of everything else that wetlands already do for us, like storing carbon, filtering out pollution, and protecting our shorelines. And others have secret underground connections that move water from one place to another. But you'd be wrong. The forested wetland gets its water from a stream that flows right by it. And the dryland wetland is connected to a river many miles away. And that means that everything we do along the way affects not only the wetland, but also the ocean and everyone and everything that depends on it. Take this wetland in South Carolina, for instance. It's home to all sorts of wildlife, including red wolves, alligators, and swallow-tailed kites. But it's also home to an ecosystem that recycles water from the air, the land, and the sky. You see, both of these wetlands are part of the same watershed, which means they're connected by streams, rivers, and eventually an ocean. Once it's there, some evaporates back into the atmosphere and some is taken up by plants and eventually released through their leaves in a process called transpiration. In fact, a river's shape is largely determined by the landscape it flows across. And the flatter the land, the fuzzier the river gets. The river that feeds it has split into a bunch of smaller channels, which has created a whole new wetland ecosystem. As water moves through the maze of channels, it comes into contact with all sorts of wetland plants, which take up nutrients and other pollutants. Their size, shape, and location all play a role in how well they can capture floodwaters, recharge groundwater, and provide habitat for wildlife. But even small wetlands can have a big impact. That's because when water flows through a wetland, it doesn't just pick up speed and keep going. I hope you learned something new about how wetlands work and why they matter. And if you did, I invite you to share this episode with someone who might be interested in wetlands or just needs a little reminder about the amazing world that surrounds us. If you want to learn more about wetlands, you can check out our website. And if you want to help bring back wetlands near you, you can visit our website to find out how. See you next time. It also slows down and spreads out, which gives it more time to interact with the wetlands plants and wildlife. And that means more opportunities to clean the water, recharge groundwater, and provide habitat for wildlife. And when it's cleaned, the water can flow out of the wetland and eventually make its way to the ocean. Now this might seem like a problem, but it's actually a pretty common and natural process. And it's creating all sorts of new habitats for plants and wildlife. For instance, the shallower water allows sunlight to reach the bottom, which supports aquatic plants like water lilies. And the tangled network of channels provides hiding spots for fish and other aquatic creatures. That's why rivers in mountainous areas tend to be narrow and fast-flowing while those in flat areas are wider and slower. But it's also why they can meander and split into multiple channels and even disappear altogether. But it's not just water that's moving through this system. Nutrients like nitrogen and phosphorus are also on the move. When water evaporates or transpires, those nutrients stay behind, building up in the wetland and making it more productive. Of course, that's not all there is to the water cycle. So even though a wetland might not look like much, it could be doing a lot of good. There's also snow, ice, and groundwater, not to mention dams, canals, and diversions that humans have built along the way. Each of these changes the way water moves through a watershed, which means that wetlands in different places work in different ways. Together, these processes move water through the wetland and back into the atmosphere. But they're also happening all over the planet. And understanding how they work in wetlands can help us understand how they work everywhere else. Water that falls as rain or snow in one part of a watershed eventually flows to the lowest point, which scientists call the outlet. In this case, that's the river. So even though this wetland doesn't look like it has a connection to flowing water, it does. And it's all thanks to where we stand on the map. Here's a wetland that relies on groundwater, but without any telltale signs on the surface. That's when water flows over the surface of the land until it reaches a stream or another body of water that eventually makes its way to the ocean. But most of the water that soaks into the ground takes a longer, more complicated path called groundwater flow. As water soaks in, it seeps through cracks and spaces in the rocks and soil until it reaches a layer of rock that is too tight for water to pass through. At that point, the water starts flowing sideways, pushed along by gravity and the pressure of the water behind it. Eventually, this underground water reaches an aquifer, which is a kind of underground lake or river. And because aquifers are connected to streams and wetlands, the water will eventually make its way to the ocean. And check out this wetland that uses capillary action to push water up through tiny spaces in the soil, allowing plants to grow in some pretty unlikely places. But with them, water has a place to go and it won't all come crashing down on your head. We dam rivers, pave over floodplains and dredge channels, making them deeper and narrower. All of this makes it harder for water to get to and from wetlands, which makes it harder for them to do all the stuff they do for us. Now sometimes these changes improve conditions for certain types of plants and wildlife, like when we build a channel that's deep enough for large boats to pass through. But overall, blocking the flow of water hurts wetlands and it hurts us. In fact, wetlands can capture excess water during storms, slowing things down and giving that water a chance to soak into the ground instead of washing away. Restoring degraded wetlands and reconnecting them to flowing waters can help them capture floodwaters, recharge groundwater supplies, provide habitat for wildlife and even take up and store carbon. In this episode, we'll explore how we can use what we know about wetland hydrology to restore and manage them for people and wildlife. And if you want to help bring back wetlands near you, we'll share some resources to help you get started. This helps prevent downstream flooding and erosion, protecting the homes and businesses nearby. The bottom line is that wetlands with connections to flowing water are better able to handle whatever Mother Nature throws at them. In this episode, we're going to look at one of the most important characteristics of wetlands, their connection to water. Now, the relationship between wetlands and flowing waters isn't always straightforward. Sometimes flowing waters are the source of the wetland's water, like when a river overflows its banks and spills onto the surrounding land, or when groundwater bubbles up to the surface. Other times the flowing water is actually coming from the wetland itself, like when water flows downhill through a swamp, or when thirsty plants suck it up out of the ground. But whether the flow is coming to or going from the wetland, it's still an important connection to have. And it's especially important when things go wrong, like when it doesn't rain for months, or when it rains so much that a hurricane is on its way. Connections to flowing water help wetlands handle both of these extremes. When it's dry, connections allow wetland plants and wildlife to tap into sources of water that might be deeper underground or further away but are still close enough to support life. Connections also help keep the wetland from drying out completely because they allow water to flow back into the wetland when it is available. A great example of this is a Florida wetland called a Pocosin. These are essentially just swamps with really sandy soil. And because of that, they rely on those connections to slow or stop flowing water from rushing right by them. Instead, that water spreads out into the surrounding landscape, which gives plants time to take up the water and lets it sink in slowly. This means that even when there's a dry spell, there's still some moisture left in the soil and it's more evenly distributed, which makes it last longer. And when there's too much water, connections to flowing waters help move it along. But having connections to flowing waters brings other benefits, too. Of course, when we build our houses, roads and farms along rivers and streams, we often block that natural flow. Luckily, there are ways that we can fix this. Wetlands are full of surprises. Some pretend to be something they're not, like this forested area in Maine that looks like woods but is actually a wetland in disguise. Now, if you've watched our previous videos about wetlands, you might think that these two wetlands aren't very connected to flowing water. Water moves through watersheds in a process called overland flow. So even though water might seem like it's just sitting in a wetland, it's likely on a journey that started far away and will end at the coast. To understand how wetlands work, we first have to understand the water cycle. And you'd be surprised how much wetlands can teach us about it. When it rains, some water soaks into the ground and some runs over the surface of the land until it reaches the wetland. For instance, in this wetland, water that falls as rain eventually makes its way to the river, where it joins all the other water flowing toward the sea. Even so, studying them can help us understand how water moves through our world, which is essential to solving some of humanity's biggest challenges. We often think of rivers as clearly defined lines on a map, but in reality they're more like fuzzy shapes that change over time. That last part is what's happening in this wetland. These changes are also helping to clean the water as it flows through the wetland. Of course, not all wetlands are created equal. Plus, small wetlands can be connected to larger ones, which creates a network of habitats that can support even more wildlife. Thanks for joining me for this episode of the Hidden World of Wetlands.